Okay. It looks like it's working. All right, so let's start. Now, so I've said previously that there's something we call the EIPs, right? Yes or yes? Can you guys hear me?
Yes.
Yes, we can hear you.
So the EIP is called the Ethereum Improvement Proposal, right? So the EIP is called the Ethereum Improvement Proposal, and I said that it is classified into different ways. So we have the network, the protocol, the metadata, the informational core. So which represents changes that are made to the Ethereum network. So amongst them we have the ERC. So we have what we call the ERC20, right? And ERC20 is what defines a standard token. A standard token. So the Ethereum paper, it makes us to realize, so it was created in 2015. It makes us to realize so the motivation, a standard interface allows any token on Ethereum to be used by other applications, from wallets to decentralized exchange. So these are now the specifications that we have for it. These are the specifications that we have for it. So which means that when you have an ERC20 token, you should have a name, a symbol, a decimal, total supply, balance of. Now this, let's take a look at the meaning of them. So this name, it defines the name of the token. It defines the name of the what? The token. Then we have the symbol that tells us, the symbol of the token. So, the name of the token can be Naira, and the symbol of Naira, we all know what the symbol is. So that's to give us an idea of the difference between a name and a symbol. Then we have the decimal. So the reason we have decimal is because in the operations that we are going to be doing in Solidity is on the group of integers. Let us understand it that way. It's on the group of integers. So let me say a set of integers. So which means that you are not going to be getting 1.2. You are not dealing with real numbers here. So you are not going to be getting anything fractional. So which means that if you require anything that you are expecting a fractional result, then it is expected of you to find a way to make it an integer. So that's the reason we have the decimals here, right? So for example, if you have a token with a decimal of 8, it means that it can be divided into this 10 to the power 8. That should be like 1 billion, right? So this method can be used to improve usability. So which means that the decimals can be used to when you are showing the user in the user interface. You can use it to like show them about them. We have the total supply, right? So the total supply, it returns the total token supply. We have the balance of, that takes in the owner and returns the balance. We have transfer. So the transfer, the person that you are transferring to, the address of the person that you are transferring to, and the value that you transferring, and it returns pool of success to, which means that if the transfer is successful, it should return success. Then we have transfer from. So the transfer from is what gives someone the ability to send from another person's account. So if you want to send from another person's purse, if you want to spend from another person's money, so you are going to make use of transfer from. And before you can do that, the person must have approved. The person must have given you an allowance. You get. So the person must have approved that you spend this money, and the amount of money that is approved for you by that person is called your allowance. So that's all. So then we just have events. So which means that an event must be triggered whenever a transfer is made or whenever an approval is made, and that's everything about the ERC20 token. So let's now write. Do we have any question before we start writing?
No question, but I just wanted to quickly say that the project that you sent to the group that you asked us to go through, I don't know why you asked us to go through, but what's the concept? Like, gone.
I can't hear you very well.
The projects that you sent to the group, like, you will tell us to go through.
Okay.
Like, I forgot that I went through. I was able to go through like just 3 of them.
Okay.
I know why you asked us to go through it too, so that's why I'm saying maybe you want us just see.
So it's just for us to see what others are building, and you can get ideas from them. That's it.
All right.
So we are going to still talk later about what we are able to see from them. So should we wait till SP comes around? What?
I said I have another question.
What's that?
This thing you are doing, on what site are you building this? Because I'm actually lost.
On what?
I mean, all this Ethereum, blah, 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 blah. I'm lost. I know I've missed a few classes and I'm not going to catch up. But then what site you want to go to be able to achieve what you're achieving? All right. Do you understand my question?
Share this one.
All right. Please, can you help me send it to the group? Thank you.
I think it's already on the group. Just tag it or pin it.
Can someone just call him so that we are going to? Okay.
Yeah, I've called him, right? So it was after I called him that he came to the group chat and said he will be joining very soon. Or do you want me to call him again?
Okay, no problem. Maybe we should just continue then.
Sumaya, I tagged you to the link.
All right, I'll check.
So if you want to write the Solidity smart contract, what we are going to start from is we are going to start from we are going to create a contract, right? So I think these are some of our own contracts when we started. Then let me check some of them. Storage, no, these are not. Owner, it only looks like, yeah, ballot. So let's create a new file here. So we are going to call it alc20.sol. So what we are going to start with is the spdx. What's there? You don't need to memorize it. As you can see here, also I need to memorize it. So it's just license identifier. So you can use MIT license or anything. So then you write pragma, solidity, then the version you want to write 0.8.21. That should be the latest version, right? Then when you want to write a contract, you are going to write the keyword contract, then the name of the contract, and you open this, right? So we know that in this we can now, what are the things that we have in this place? So the first thing is we have the name, right? So we need to return this function signature. So we want to have the name. So the first thing that we are going to do is what? We are going to have a stage variable. We can have what? String private name. So we can use this one to what? To store the name. Let's say that the name is pattern token. So after every this thing, you need to end it with, you end every statement with a semicolon. You end every statement with a semicolon. Then if you have that, so let's just have a function, right? So the function name, it takes in nothing. It should be external, right? Returns string. So here we are going to return the name. So since this one is only reading a state variable, it's not writing to it, then we are going to call it a what? It is a view function. So here it's going to be memory. Yeah. So we have that. We started here like that, as simple as that. So the next one is symbol, right? So you can say that the symbol string private symbol right. Then here we have symbol external view returns string memory. So this one too should return symbol. The next one is decimals. So you can have here again string private underscore decimal. So decimal shouldn't be string, it should be unit 8 is enough, right? Equals to 8. So here we have function decimal external view returns unit 8, right? So this returns the decimal also. So is this decimal or decimals? So it is decimals. Next we have total supply, right? So this one is going to be unit 256, that's the highest. So private total supply. So in this place it's just going to be 0, right? It's starting from 0. Then function total supply external view returns unit 256 return total supply. Then what again? Balance off. So balance off is going to it returns the account balance. So if you look at this function signature, it's going to take in the owner address and return the balance of the person, right? So for that one we are going to use mapping private. So we are going to take address to unit 256 and we call it what? Balance of. Right? So I think this private is supposed to come where? Let me see. Okay, yeah. So which means that in this place now we have function balance of. So this one is going to take address of the owner external view returns unit 256. So it returns the balance of the owner. So for mapping, this is how you return it. Balance of the owner, right? Then we have transfer, right? So if you want to transfer, so there is something that we are going to do for this one. We need an helper function. So let's have another transfer. So we have a transfer. This one is going to be, we want to transfer from address from. We are transferring to address 2 and we are transferring this value. right? So this is going to be an internal function. This is going to be an internal function. So let's assume it's not returning anything. So the first thing that for transfer from, what we want to do, when you say that you want to transfer value from one person to another, right? What you are just doing is at the from balance, you are going to reduce that from's balance and you are going to increase the to's balance, right?
Musa,
Yeah.
I think the two last functions that are like root transfer. Is the last one not meant to be transfer from?
It is transfer.
The last two, right?
Yeah. So this one, you can see, that's what I'm saying, that this one is an internal function. This is an helper function. So
Okay.
this one, you can see I have underscore here to show you that it is an internal function. I have not written this one yet, right?
Okay.
So this one, we are going to be calling it whenever we want to do transfer. So we are going to see the difference between the two. So if you want to do transfer, what we are simply doing is the balance of the what's it called, the person you are transferring from. You want to make sure that the balance of the person is greater than the value you want to transfer. Then you so the first thing is you want to assert. You assert that the balance of address from is greater than or equal to the value.
Did not use answer to the first time. How come? What's going on? It's required we use. It's required we use.
So there is something. So we have assert, require, and revert.
And what?
Revert.
Okay.
So we can use, when you use assert, you only need to, you don't need what's it called? You are not going to give an error message.
Okay.
So when you use require,
You
give
can have an error message.
But if you revert doesn't, you don't need a condition to revert. If you use, when you assert or you require, it's going to revert if the condition is not met. So let's require. So we require the balance from is greater than or equal to the value. Else we say not enough money. Then after we've assert, then let me just put this one here. So we are going to require that not enough money. Then we now say that what the balance of address from we are going to reduce the value there, and the balance of address to we are going to increase the value there, and that's all. What's this? Oh, okay. So this is the when we now do this, we are going to emit an event. So in this place we have an event. So event names are started with capital letter. So transfer events, let's look at how transfer event is. You see we have address from
Okay,
Sure.
I found this on the web for have a GX from 2 and value. Check it out.
So address, this will be from, then address, this will be 2, then units 256 for value. So in this place we are just going to emit the event, emit the transfer event, and it takes in from, to, and value, right? So we now come back to this place. If you want to transfer, right, from in this case now, so what we just want to do is we want to transfer from a particular address. So we have no, you want to transfer to a particular person. So when you use this one, it means that you are transferring from yourself and you have value that you want to transfer. Right? So which means that what we are going to do basically is we are going to get the message that we are just going to call that internal function transfer, and the address from is going to be msd.sender. Address 2 will be 2, and that one will be what? Value. Now you see that for the transfer it also has the return of success, right? Where is it? So then which means that we should have returns to success, right?
Sorry, where is msd.sender coming from?
It's a global variable.
Okay.
So msd.sender is a global variable which holds the address of the person interacting with the contract. Do you get? So after the transfer, then we return success. We return true. We return true. So this is transfer. Then the next one we have transfer from. So if you want to transfer from, we have owner, right? Then address you want to transfer to, and the person you want to transfer to, and the value you want to transfer. So for this one also is external and returns bool of success, right? So in this case now, before you can use transfer from, there has to be what? There has to be allowance, and so you need to do this allowance. So in this place we are going to have another mapping. This one is going to be a 2D mapping. So we are going to map address of owner to the mapping of address of spenders to their amount that you want to give them. Right? To the amount that you want to give them. Then transfer from so in this place, the first thing that you are just going to do is you want to require that the allowance of the owner to the person interacting with the contract is greater than or equal to the value you want to send. Else you say what? Not enough allowance. Right? So which means that if there is enough allowance, then you can now transfer from the owner to the spender. This one should be spender. No, this one is 2. This one is from the owner to address 2 value. Do you see that we don't have to rewrite all this transfer logic again? We just have it here, right? Then we are going to return true. We are going to return true. What happened? So this is transfer from that we've implemented here. Now we now have another function after this, which is the approve. So approve simply is, where is it? Approve simply is you are giving a spender the opportunity of what? Spending your money. So we have approve. So we have address. You are going to take in address of spender and the amount you want to approve. So this is going to be an external returns rule. So in this case, what you are simply going to do is for the approve, you are going to set the allowance of the spender. So the allowance of yourself, so message.sender to the owner, the spender, will be equal to the amount. It will be equal to the amount. Then we are going to return true. So there is a function that we emit whenever there is allowance also, so which is the approval. So we are going to create the event approval. So we have the address, we index it, of the owner, and address of the spender, and the value, right? And the value. So after that, where are we? So in this place now, we are going to do approval. So you are the one approving, you are the MSG.sender, you are the owner, then the spender, then the amount. So we are going to emit it. That's the approval, right? So when you transfer, when you do transfer from, when you do transfer from, you're also going to reduce the allowance of the MSG.sender from the allowance of the owner, from MSG.sender. You are going to reduce it by that value, right? When you do transfer from, you are going to reduce it by this value, then you transfer. So when you disapprove, approve is going to override it. It doesn't increase it. It overrides the allowance. So the next one is allowance. So if you want to know the allowance, this one is going to be function allowance. It takes in the address of the owner and the address of the spender. So it's an external function, a view function, because it's not writing to state, and it returns unit 256. So this one, you just return the allowance of the owner from the spender. Overturn. What's the next thing? So that's allowance, approve allowance. So we are done with this specification, but then there are still some more. So there is also this one internal function. There are still some other internal functions that you need to also know. So there's something we call minting, right? There's something we call minting, and there's something we call burning. So when you mint money, it means that you are creating money from nowhere. Something like what's that guy's name? When Emefiele, when he minted new money, so that's creating money from nowhere, right? So which means that we can have an internal function. So the mint, right? So and for minting, the address that you want to mint to and the value that you want to mint. So it's an internal function, and it returns, does it return anything? Let it return bullshit. Should it return? Since it's an internal function, no, it shouldn't return. So when you want to mint, right? Minting means that you are going to, so basically for minting, you are just going to increase the person's balance. So the balance of who you are minting to, you are going to increase it by the value, right? Then you are going to emit the transfer event. So where the address from will now be address 0. That is, you are creating it from nowhere. So this one is going to be for 2, and this one is going to be value. So that is minting. It doesn't return.
Sorry, why are we calling transfer inside mint? I thought total supply we are supposed to.
Oh, thank you. That one also. Thank you. So it will also increase the total supply. total supply. So it will also increase the total supply by the value. So which means that you see that it is the at default the total supply is 0. So it is when you mint, that's when money is created into the ecosystem. When the token is created, the token is created by minting. So which means that when you are transferring from one place to another, you are just like passing the money that is already created. So when you want to remove money from the system, we have the burn function. So the burn, it has address that you want to burn from. So I think this burn basically just have the value that you want to burn. It is an internal function, right? And it's going to reduce your total supply. It's going to reduce the msd.sender. It's going to reduce your value of the token. Then it will reduce the total supply. And it's also going to emit the transfer event. So in this case now, you are transferring, you are the msd.sender, you are transferring to address 0, right? Value. So there's actually a check that we usually do, right, for most of these things that I have neglected. And the check is that we don't want burn. Okay, this is supposed to be units 5, 6. So is that in most of these things, you don't want someone to transfer to address 0. So whenever you want to transfer, so inside this transfer, this thing, where is our internal transfer? So we can also like require that address 2, that 2 is not equal to address 0, so that you don't mistakenly burn your money. Because when you transfer to address 0, you cannot recover it. So that's the reason it is used to implement the burn function. So when you transfer to address 0, that's the end of it. So we have the burn, we have the mint, we have transfer, allowance, approve, transfer from, transfer. So this is pretty much everything. Now, so with the way it is now, we can now, with the burn, with the mint function, we can now implement some more functions, which is, let's say that we want to buy token. So function buy token. So if you want to buy token, just tell us the value that you want to buy. I need to go
You
now.
don't put your units.
This value also. So external, we can make it payable. No, don't let us make this one payable. So yeah, so if you want people to like pay money in order to buy your token, so you are going to make it what? Just write payable there, and yeah, you should return bool. So which means that for this one, so when people want to buy token like that, so you can also require that msd.value is greater than 0. Pay money, bro.
So this MSD of value is returning the balance of the sender.
No. msd.value is returning the amount that the person transferred while sending the money.
I didn't get that.
The amount. So it's like when you want to interact with the contract, you are sending money along.
Okay.
So that money that you send along is retrieved using MSD.value.
Okay. Okay. I think I get. I'll continue.
Okay. So what's the next thing? So after you've required that, then you can now say that you want to mint. You can now
It's just 1 minute to 6.
yes,
I'm guessing you have a minute by 6.
yes. So you can continue from here, right? Just teach them how to verify.
I didn't join in my system.
You can use your mouth to explain it to them. And from
My
from
mouth.
from what I said
My mouth,
even earlier,
okay.
from what I even said earlier, assuming they had copied the code that was there before and tried to verify that, so they just know that
Yeah.
now they already know
It's just to
write the
explain.
code. So the token, let me try to join this one with my phone. Immediately the class starts, I would leave.
Okay. This call will even end in 4 minutes.
Oh, that's cool. Oh, class has started.
Hello. Hello, Diego. Good afternoon. Hi, how's everyone doing?
So, it's like this way we are going to stop the
Oh, that's a
class.
nice cap. Yes.
Enjoy your weekend.
Last Friday we were.
Weekend. Weekend. Which weekend?
It's not
On
about
a
the
Monday.
Oh,
And this goes
okay.
well with the bootcamp.
Weekend is a state of
But now
mind.
that I realized,
So, this way we are going to
God,
stop for
when?
today.
just hold on a second.
Yeah.
So that
So you can just
you-
continue with how to deploy and verify the contract.
Yeah, did anybody